So now let us continue for the next subtopic, first shift of inverse Laplace transform. So you can refer to the textbook, theorem 4.5, page 141. Laplace inverse Fs is equal to Ft and A is a constant. Then Laplace inverse Fs minus A is equal to exponent At multiplied with the Ft. So this one is also can be written as exponent At multiplied with the Laplace inverse of Fs. So this is the theorem for the first shift property of inverse Laplace transform. So the hint for the first shift of inverse Laplace transform is whereby you have the numerator that contain s, which is not same as the denominator. So now I will explain how to change the numerator that contain s in order to make it become same thing as the denominator. Example 1, how to change the numerator. You have s at the upper side, but at the bottom side we have s minus 3 with the power of 4. Okay, so now we want to make s at the upper side become the same thing as the bottom side. So s at the upper side will become s minus 3 plus back with 3 divide with s minus 3 the power of 4. So this is how we have to change s at the upper side to make it become same thing as the denominator. If you have s minus, so the upper side will become s minus and plus back with the same number. So let us continue for the second example. We have s over s plus 3 with the power of 4. So now the bottom side you have s plus 3. So the upper side will become s plus 3 minus 3 divide with s plus 3 the power of 4. So if we have s plus at the bottom side, so the upper side will become s plus 3 and then we have to minus back with 3. So this example, I only show how to change s in order to make it become same thing as the denominator. So now let us continue for the third example. We have 5s minus 2 at the upper side. At the bottom side, we have s plus 3 with the power of 4. So now we want to change this s to make it become the same thing as the denominator. 5 multiplied with s. So the s will become 5, make it in the square bracket. So in this square bracket, we will change the s to become s plus 3 minus with 3. S plus 3 minus back with 3. And negative 2 here, we'll write at the behind here minus 2. Divide the whole thing, s plus 3 the power of 4. So now if we have a constant at the front here, the constant should be multiplied inside but only at the front of the square bracket. 5 multiply s plus 3, 5 multiply with the negative 3, negative 15. Negative 2 at the behind here, minus 2. Divide the whole thing, s plus 3 the power of 4. Okay. So s plus 3 here, we are not going to multiply everything here. Why we will not multiply? Because we want to make the same term s plus 3 at the upper side as the same term as the s plus 3 at the bottom side. So we only can simplify the number here. Negative 15 minus 2 will become negative 17. Okay, so this is how we can simplify or we can change s at the upper side to make it become same term as the denominator. So now let us continue for the next example. 5s minus 2 at the upper side, divide with s plus 3 with the power of 2 minus with 2. So we want to change this s, make it become the same thing with the s at the denominator. So 5 multiply. So in this square bracket, we want to change the s to make it become the same thing as the s at the denominator. So s will become s plus 3 minus 3. Minus 2 at the behind here, we will write minus 2 at the behind of the square bracket. Divide the whole thing. S plus 3 the power of 2 minus 2. So now you have a constant 5 at the front here. You have to multiply at the front of the square bracket. 5 multiply s plus 3. 5 multiply with the negative 3. Negative 15. Minus 2 at the behind. Minus 2. Divide s plus 3 the power of 2 minus 2. So the same thing, we only can simplify the constant at the behind here. S plus 3 here, we cannot simplify because we want to make it the same thing as the denominator. Negative 15 minus 2 will become negative 17. S plus 3 the power of 2 minus 2. Okay, so this is how we can change or we can reduce s at the upper side in order to make it become same thing as the denominator. So for this example, I only show how to change the numerator in order to make it same thing as the denominator. Before we go for the example 4.10, page 142, so I will explain the step for the inverse Laplace transform by using first shift property. Okay, step for the first shift property inverse Laplace transform, there are 3 steps. The first one, determine the value of a from s minus a the power of 2 or s plus a with the power of 2. So for here, it depends whether you have power 2 or whatever power here. So example, if s minus 7 with the power of 2, our a is equal to positive 7. If s plus 7 the power of 2, our a is equal to negative 7. Step number 2, create or write exponent at at the front of the Laplace inverse curly bracket, and then you have to change position of s minus a the power of 2 or s plus a with the power of 2 to become s. So the same thing here is depend whether you have power 2 or whatever power here. Step number 3, refer table of the Laplace transform in order to solve inverse Laplace transform. So this is the step that you have to follow in order to solve inverse Laplace transform by using first shift property. Okay, now let us continue to solve this example. Find inverse Laplace transform of the following function. So we have negative 6 over s minus 2 the power of 2 minus 4. So if you can refer back to my notes before this, I have mentioned that hint for the first shift inverse Laplace transform, whereby we have numerator that contain s, which is not same as the denominator. Okay, so this is the hint for the first shift inverse Laplace transform. Okay, refer back to the example. If we have s at the upper side, which is not the same thing as s at the bottom side, means that you have to solve by using first shift inverse Laplace transform. For example A here, we don't have any s at the upper side, but at the bottom side we have s. Okay, so this one is also considered for the first shift inverse Laplace transform. Example B here, we have 3s minus 6 divide with s minus 1 the power of 2. So s at the upper side is not the same thing with the s at the bottom side. So you have to apply first shift inverse Laplace transform. Okay, now let us try to solve this example. You are given negative 6 over s minus 2 square minus 4. So as we can see here, there is no s at the upper side, but we have s minus 2 at the bottom side. So this one is also considered as the first shift inverse Laplace transform. So the first step, you have to write Laplace inverse curly bracket for the whole thing. So now you have to refer to the step of first shift inverse Laplace transform. So there are 3 steps. The first step, determine value A. The second step, write exponent AT and change s minus A or s plus A become s. Step number 3, refer table of Laplace transform. So step number 1, determine value of A from s minus A or s plus A. So we have s minus A square. So means that our A is equal to positive 2. So now step number 2, write exponent AT and change s minus A or s plus A to become s. So for our question, we have s minus 2 the power of 2. So we will change s minus 2 to become s. Write exponent AT, exponent 2t, Laplace inverse, curly bracket, negative 6 at the upper side. So negative 6 divide with s minus 2 square, we will change it become s the power of 2 minus 4. So now, if you have any constant at the upper side, you have to bring to the front. So actually from the beginning here, you can directly bring any constant to the front. So bring negative 6 to the front will become negative 6 exponent 2t Laplace inverse 1 over s square minus 4. So now step number 3, refer to the table of the Laplace transform in order to solve Laplace inverse 1 over s square minus 4. So by refer to the table, Laplace inverse a constant at the upper side, and we have s square minus a number at the bottom side. The suitable one is a over s square minus a square, which will become sin h of at. So now we have to determine what is the value of a from a square. So from here, a square is equal to 4. So therefore our a is equal to 2. So we only consider positive value. So now you have to write back Laplace inverse 1 over s square minus 4 in the terms of a over s square minus a square. So it must be value of a at the upper side. So from original here we have 1. So you have to write back in terms of a over s square minus 4. So 1 here will become a, which is a equal to 2. S square minus 4, s square minus 4. So it depends either you want to write s square minus 4 or s square minus 2 square. So now we write at the upper side as 2. So you have to divide at the front with 2. Divide with 2. So now simplify your answer. Laplace inverse 2 over s square minus 4 will become sin h of at. Negative 6 over 2 will become negative 3 exponent 2t. Laplace inverse 2 over s square minus 4 will become sin h of at, sin h of 2t. So this is the answer for the inverse Laplace transform by using first shift property example A. Okay, now let us continue for the example B. 3s minus 6 divided with s minus 1 square plus with 5. So as we can see here, s at the upper side is not the same thing as at the bottom side. So the first step, write Laplace inverse, curly bracket for the whole thing. So now we have to reduce s at the upper side in order to make it become the same thing as at the bottom side. So s at the bottom side is s minus 1. So s at the upper side, we have to change it become s minus 1 plus with 1. Square bracket. So in this square bracket, we will change the position of s to make it become s minus 1 plus with 1. S minus 1 plus 1. So negative 6 here, we will write at the behind here negative 6. Divide the whole thing, the same thing as the denominator, s minus 1 square plus with 5. So for the previous example, you have learned that if you have any constant, you have to multiply the constant at the front of the bracket. So Laplace inverse, 3 multiply at the front of the bracket s minus 1, 3 in the bracket s minus 1, 3 multiply with 1 will become plus 3. Minus 6, divide the whole thing, s minus 1 square plus with 5. So now you have to simplify. So simplify the constant means that you have to simplify negative 3 minus with 6. S minus 1, positive 3 minus 6 will become negative 3. Divide the whole thing, s minus 1 square plus with 5. So we have minus operation at the upper side, therefore you have to apply the linearity whereby you have to separate the terms. Now you have one curly bracket. When you separate the terms, there will be two curly bracket. Laplace inverse, the first curly bracket, minus operation, minus Laplace inverse, the second one curly bracket. So for the first curly bracket here, we will write 3s minus 1 divide with s minus 1 square plus with 5. 3s minus 1 divide s minus 1 square plus with 5. For the second curly bracket here, we will write 3 over s minus 1 square plus with 5. 3 over s minus 1 square plus with 5. So now if you have any constant, then you have to bring the constant to the outside. So for the first curly bracket, we have constant 3. So we bring constant 3 to the front. 3 Laplace inverse s minus 1 divide with s minus 1 square plus with 5. The second curly bracket, we also have 3. So bring 3 to the front will become minus 3 Laplace inverse 1 over s minus 1 square plus with 5. So now we will apply the first shift property for the inverse Laplace transform. We have s at the upper side, s minus 1, divide with the s minus 1 at the bottom side. Now apply first shift inverse Laplace transform. So you have to go through to the 3 steps of the first shift inverse Laplace transform. You have to determine the value of a from s minus 1 the power of 2. So we have here s minus 1, which is the same thing s minus 1 at the upper side. So we determine the value of a from s minus 1 the power of 2 or without the power here. Okay, so from s minus 1 the power of 2, our a is equal to positive 1. So step number 2, you have to write the exponent at the front of the Laplace inverse. And then we have to change s minus 1 to become s. So therefore, 3 Laplace inverse, write exponent at the front of the Laplace inverse. So 3 exponent t, change position s minus 1 to become s. So s minus 1 at the upper side will become s, divide with s minus 1 square at the bottom side will become s square plus with 5 minus the same thing for the second curly bracket. We determine the value of a from s minus 1 square. So which is our a is equal to 1. The second step, write exponent at at the front of the Laplace inverse. So our answer will become minus 3 exponent t Laplace inverse. 1 at the upper side, we don't change 1 over s minus 1 square at the bottom side will become s square plus with 5. So now from here, we have to refer to the table of the Laplace transform, for which part you have s at the upper side, divide with s square plus a constant at the behind. Now refer table of Laplace transform. So by refer to the table of the Laplace transform, whereby we have s at the upper side and s square plus a constant at the bottom, the suitable one is s over s square plus a square, whereby the answer will become cos of at. For the second Laplace inverse, you have a constant at the upper side and s square plus a square at the bottom side. The suitable one is a over s square plus a square, whereby the answer will become sine of at. So therefore, 3 exponent t Laplace inverse s over s square plus 5, whereby s over s square plus a square will become cos of at. So we have to determine what is the value of a here. So from here, a square is equal to 5. Therefore, our a is equal to square root of 5. So the same thing for here, our a square is equal to 5. So therefore, our a is equal to square root of 5. So Laplace inverse s over s square plus 5 will become cos of at. Cos of square root 5t minus 3 exponent t Laplace inverse 1 over s square plus 5. We have to write a at the upper side. So this one in terms of 1. So you have to write square root of 5. Laplace inverse square root of 5. So when we write square root of 5 at the upper side here, you have to divide with square root of 5 at the front. Therefore, the whole thing will become 3 exponent t cos square root 5t minus 3 over square root 5 here will become 3 over square root 5 exponent t. Laplace inverse square root 5 over s squared plus 5 will become sine of at, whereby our a is equal to square root of 5. So sine of square root of 5t. So this is the answer for the second example, whereby we apply linearity and then we apply first shift of inverse Laplace transform. Okay, now let us proceed for the next example. Exercise 4.7, page 143. Find inverse Laplace transform for the following function. We have 3 over 2s plus 5 with the power of 3. So as we can see here, there is no s at the upper side, but at the bottom side we have s plus 5. So you should know that you have to apply first shift for the inverse Laplace transform. Okay, first step, you have to write Laplace inverse, curly bracket for the whole thing. Okay, if we have s at the upper side, you have to change s at the upper side to make it become same thing as at the bottom side. But now we don't have any s at the upper side here. But at the bottom side here, we have 2 multiply with s. So you have to factorize the constant first. Laplace inverse 3 over. So when we want to factorize any number beside s at the denominator, we still write the terms inside the curly bracket. So 2 inside the curly bracket. So this one 2s plus 5, the whole thing with the power of 3. So 2 we want to factorize, and the whole thing here must be power of 3. Power 3. 2 multiply with what? So that it will become 2s. So 2 multiply with s. Plus with 2 multiply with what? So that it will become 5. So this one will become 5 over 2. So now we can simplify. And then you have to bring the constant to the outside. So let us simplify first. Laplace inverse 3 over 2 the power of 3, because the whole thing here with the power of 3. So 2 power of 3 will become 8 multiply s plus 5 over 2 the power of 3. So now we can bring the constant to the outside, which is 3 and 8. 3 over 8 Laplace inverse. So the upper side will become 1 over s plus 5 over 2 the power of 3. So now we will apply first shift for the inverse Laplace transform. So the first step, you have to determine the value of a. From s plus 5 over 2. So therefore our a will become negative 5 over 2. So the second step, you have to write exponent at and change s plus 5 over 2 to become s. So from s plus 5 over 2, we have determined our a is negative 5 over 2. 3 over 8, write exponent at. So exponent a, negative 5 over 2t, Laplace inverse, change position s plus 5 over 2 to become s. So we have s plus 5 over 2 the power of 3. So s plus 5 over 2 will become 1 over s the power of 3. So from here, step number 3, refer to the table of the Laplace transform. So you have to refer to the table of the Laplace transform whereby we have s with the power at the bottom side. The suitable one is n factorial over Sn plus 1, whereby the answer will become t the power of n. So now we have to determine what is the value of n. From here, we have s the power of 3. N plus 1 is equal to 3, so therefore n is equal to 2. So once we obtain the value of n here, you have to write in terms of n factorial over Sn plus 1. So Laplace inverse 1 over s the power of 3, you have to write in terms of n factorial over Sn plus 1. So 3 over 8 exponent negative 5 over 2t, Laplace inverse 1 here, you have to write in terms of n factorial. 2 factorial divide with Sn plus 1. So Sn plus 1 is s the power of 3. S the power of 3. So once you multiply 2 factorial here, you have to divide with 2 factorial at the front here. Divide with 2 factorial. So now simplify your answer. 3 over 8 divide with 2 factorial will become 3 over 16 exponent negative 5 over 2t. Laplace inverse 2 factorial over s the power of 3 will become t the power of n, whereby our n is equal to 2. So t the power of 2. So this is our final answer for this example.